Okay, this is a recall question. So we need to bear in mind that in a Brownian motion experiment, the bright specks that we see through the microscope is actually the smoke particles. So what is actually seen will be the random movement of the smoke particles. B. The boiling water is at 100 degrees Celsius. So since the metal bar is in contact with the boiling water, the leftmost part of the metal bar should have reached thermal equilibrium with the boiling water, so it should be 100 degrees Celsius as well. And as the distance gets longer, the temperature should decrease because the heat is being conducted from the left side to the right side. And eventually, the wax started to melt. So the temperature at the wax, it should be greater than 20 degrees Celsius, which is the initial temperature. So with this, we can conclude that the temperature distance graph should look like option D, where the beginning part of the rod is at 100 degrees Celsius and the temperature starts to decrease as the distance gets longer and longer along the rod, and at the end of the rod it should have a temperature that is greater than 20 degrees Celsius. So answer D. Okay, for this question, right, we need to look at the working principle of a thermocouple. Okay, for a thermocouple to work, firstly we need to have two wires of different material. So in this case, wire X can only be iron. And secondly, the temperature between the two junctions, which are the hot junction and the cold junction here, must be different. So we can say that the cold junction must definitely be colder than the hot junction in order for an EMF to be registered in the voltmeter. So the answer should be B. Okay, for this question, we are given the mass of the air and the thermal energy gained by the air, as well as the specific heat capacity of the air. So to find the temperature rise, we can use this formula. Energy is equal to mc theta, and theta is equal to energy divided by mass times the specific heat capacity, and this will give us 2000 divided by the mass. We can keep it in gram because the unit of the specific capacity is in joule per gram degree Celsius. So it will be just 75 multiplied by 1.1. That will give us the answer as C. The diagram here shows us a displacement time graph. So to find the amplitude, right, we will take the distance from the zero displacement to either the highest point of the graph or the lowest point of the graph. Okay, and this is represented by P, which is the amplitude. And to find the period, we can take the time taken for one complete wave, and this is represented by Q, which is the period. So the answer should be A. And some candidate make a careless mistake to say that Q is actually the wavelength. Q is only the wavelength when this graph is a displacement distance graph.